In this video, we'll be talking about controlling timers, how we actually set them up and use them. So firstly, we've got that TAX, TA0 or 1, CTL, the control register. And that's the control register for the whole timer. It allows us to set up things like our clock source, so which clock are we actually going to use? An input divider for the clock, so do we slow it down, like do we divide it by 2 or 4 or something like that? It allows us to set the mode, so are we using up mode, up-down mode, continuous mode, where it counts from 0 to FFFF, or stop, which is essentially where the timer's off. And finally, it allows us to enable or disable interrupts through our timeout periods there. So they're some of the things that our control register allows us to set up. This is directly out of the data sheet that shows you the particular bits within each of those registers that we're using to set up a particular timer. Our next ones are these ones, the TA0 or 1, CCR0, 1 and 2 registers. And these are the comparison registers. These registers are compared against our timer count register, and things can occur. We can generate interrupts and things when each of these happen. We have 3 of these registers per timer, so you'll see that there's 3 for timer 0 and there's 3 for timer 1, and they're named appropriately. And if we've enabled it, these can generate an interrupt or toggle a particular pin when they equal whatever the count value is in the TA0 or 1 R register. And finally, we have our control registers. And we have a control register for each one of those comparison registers that we have here and we looked at previously. Basically, it allows us to set up each of those comparison registers individually. Now, when we're talking about using them to generate interrupts and pins, here's some of the important bits involved. Bits 15 to 10 are talking about our capture mode. This is if we're trying to time external signals coming into our microcontroller and work out how long a pin's been high or low for example. That's not something we do so much in the lab. Bits 5 to 7 are more about the output mode that we use for toggling pins, and that is something that we use a fair bit in the lab. Bit 4 is to enable or disable the interrupt when that timer count value equals a specific register. Very, very handy, because we can turn off individual timer comparisons. So we might be using 1, but we're not using 2 and 0, for example. Our output bits mode, so those bits 5 to 7, we've got a number of different ways that we can control how it will generate and how it will control an output pin. They are things like set reset, so when the timer value equals something, equals our count value, we can set the pin to a 1. When it times out, it can equal a 0. We can set it to toggle, so every time it's equal to that, it'll toggle. And we can do the reset set, where it resets where our timer comparison value is the same as what's in our count value, and then set it when it resets the timer count value. So a few different ways around it. And here's what's in one of those particular control registers. You'll notice there we've also got the CCIE, the enable interrupt, and we've got one of each of these for each of those particular comparison registers available to us. So how do we control pins with a timer? We can use them to control some pins, but not all the pins, because specific pins, and not all of those pins in fact, are connected to specific timers. And so you'll see here some of the pins have something that will be written as in TA1.0 or TA0.0 or something like that. And what that's basically meaning is that pin can be connected to timer 1 comparison register 0 or timer 1 comparison register for 1 for TA1.1. So you'll see in our little diagram there, some of them are connected, but not all of them are connected. And so when we're designing our schematic, if we want to use something that has a timer pin associated with it, we need to connect it to the right thing. Otherwise, we'll be doing all sorts of annoying things and generating interrupts to then try and flip a bit. We want to avoid doing anything like that. So to use the timer, here's basically what we do. We set the timer and set it to stop mode, because we don't want the timer to be running while we're trying to set it up. We set up the comparison registers to the value that we want to compare at. So put in F010, whatever value that we want for comparison. We set up our clock divider, and we set that based on how long we want our timer to operate over. So if we're timing short time intervals, we probably don't want to divide by anything. Divide by 1, which is just take the straight clock. But if we're timing longer time intervals, we'll need the clock to be going for longer. So we divide by 4 or 8 or something like that to slow it down. If we're driving a particular pin, we need to set the relative P1 or P2 select bit for that particular pin to connect that pin to the timer. And we choose the mode for it. So we start it. We put it in up mode, continuous, or up down mode. And that sets our timer off and away. Next, we'll look at a few worked examples for how we actually use timers to do these sort of things.